Right, great. Thanks, Kevin. Thanks for inviting me along today. I want to talk about something I'm passionate about, which is application security. I know it's a thing that tends to get lost last on the requirements list, but these days it's becoming more and more important. So this talk's all about how we get a decent level of security and automate the discovery of security whilst we're developing. So we're building in security as we're going along. My name is John Staveley. I'm an IT contractor. You can reach me on Twitter or LinkedIn. This is the 4th time I've done this talk, so hopefully it should be pretty plain sailing. I've not managed to do it in less than an hour and a quarter yet, so I apologise if you're used to it on an hour, but there's a lot of material to get through. So tonight's talk's about DevSecOps. So it's a very sexy term, DevOps, and Sec is just like the security aspects of DevOps and what's called pulling the security left. So getting more of the security built in as you're doing the requirements, you're coding, you're building, deploying and testing. Amplifying security feedback, so getting feedback from deployed environments and then putting them back into the requirements pipeline. Working with an overall higher security baseline, so working with a set of secure by defaults that have been rigorously tested. So I'll be going into the demo project that goes along with this. And also a reproducible security-focused deployment using Azure pipelines in Azure Devops. So that's the build agent and using ARM templates to set up all of the infrastructure. So tonight I'm going to talk a lot about tooling. So doing a little bit of lightweight threat modeling. So this isn't a sort of bureaucratic gating process. This is practical steps on how to build in security when you're using infrastructure perhaps you're not familiar with. What you can do in the IDE, limited though it is, static analysis. So that's analysis of your code, the infrastructure platform, components like NuGet packages you're using, and some example security unit tests you can use in your code. Finishing it off with some dynamic analysis, so OWASP SAP, so it's pen test light, and then what security acceptance tests you can do. So all of those stages are then feeding security back into your requirements, so you avoid having to do security regression, having insecure code in production. So I'm not suggesting that anyone does extensive notes tonight. All of the slides are on SlideShare. Go and steal them. All the code is on GitHub. Go and steal that as well. I'll give you the URLs for that at the end of the talk. So why should we bother about security? Well, EasyJet admits they got 9 million users hacked. That happened about a month ago. The fine is in the pipeline with that. GDPR is going to ensure that they will pay a high price for doing that. And then British Airways, 183 million £3 fine for a data breach. Marriott Hotels, Instagram, Australian healthcare, American corporate, government, banks, you name it, they're all getting hacked, spilling customers' data, and they're losing credibility. And with GDPR, it means it's going to create fines, even after we leave the EU, because we have to work within the EU. So how am I approaching security? So DevSecOps is just DevOps with a bit of focus on security. So DevOps is all about a fast flow of work from dev into operations. So I do the requirements, I do the build, continuous integration, promotion to production, and operations, the people who operate it, work with what I've deployed, and then feedback any issues. So pushing code out into production quickly, amplifying security feedback loops. So we're going to what feedback loops we can get from the Azure platform, focusing on improvement of daily security work, working with a default secure platform. So developers never going in and just going, oh, well, I need an app service, I'll just click add one. They're going to go, well, I've got this secure template, it's been pen tested, it's been run through security checks already, and we use that as a basis rather than something that's a bit plain vanilla. So what do we mean by plain left? So if you look at a standard waterfall development cycle, you've got requirements design, coding, testing, fixing the bugs, hardening, which is usually a pen test, and then into production. Now, pen tests are usually the way of ensuring security in today's environment, but it's very sort of waterfall-y. You know, really you should be building in security at every one of those stages. So if I get a small requirement for my sprint, I do the requirements for that, I do the design, coding, and testing, and then hardening in production for that small item of code. And yes, you're still doing pen tests after that, but the pen test is really feeding back into all of those stages and saying, how could we do the requirements better? How could we do the design better? How could we do the coding better? So try and pick up those security defects earlier. So overall, it means fewer security defects. It's an average reduced time to detect a security issue because of the security feedback and continuous testing. The automation means when you're promoting into production, if you've got a security bug, you can fix it quickly and push it all the way through into production quicker. Providing a moving target to hackers has been proven in various studies to mean that it's more difficult for them to hack you because your system's changing more rapidly. If you've got a system that only changes every 6 months, then it's a lot easier to hack. And of course, the old one, fixing production is 6 times more expensive than fixing in design. So we need to catch those security defects as soon as possible. So what are we going to secure? So about 4 years ago, I did a talk at dotnetsheff about application security. So it captures cross-site scripting, SQL injection. It's got a secure account management process, a strong password hashing and data encryption algorithm, forces SSL, cross-site request forgery, all the right HTTP headers, all that kind of jazz. So that came out of that came a project on GitHub with which is in full-fat.net. I know, a lot of people aren't using full-fat.net these days, so but that's not really the point. This talk's not about that. But I had to deploy something, so I used that as a basis. But it's still a very good, strong example project because I maintained it over the years. If you want to retrofit security onto a .NET project, so all of that's on GitHub. In terms of the platform, it's got an app service which serves the web pages. Behind that is a SQL Azure instance. The secrets are kept in the Key Vault, Azure Key Vault. I've got blob storage behind that. We've got best of breed firewall in terms of Cloudflare. So that's the bit that's not in Azure. And then there's a window into the World Wide Web. And you hear that you've got your happy customer trying to spend money with you and your nefarious actor who's trying to steal your secrets. So that's what we're going to deploy in terms of platform with the Security Essentials project deployed on top of it. So all of the demo code's there. It uses infrastructure as code. So that's done mostly using an ARM template and some PowerShell. All of the Cloudflare setup's done using PowerShell. So all sorts of various security goodness Cloudflare gives you. Forces TLS version 1.2, HTTP2, enables the WAF so it can spot SQL injection, cross-site scripting attacks, that kind of thing. Protects against denial of service, which is, in my view, the strongest reason for using it. So in the application code, we lock down the Azure App Service so it can only be accessed via Cloudflare. We're using the Key Vault to protect our secrets, locking down the app service and the blob storage so it sits on the same virtual network. So there's a strong closed network between the two assets, which can't be accessed from the outside. In terms of blob storage, SQL, we've got some strong secure by default, so encryption at rest and at transit, and then data encryption for SQL, weekly vulnerability scans, backups for availability, and that kind of thing. Okay. Okay, so we've got this part of the application here, which handles all the deployment of the infrastructure. So it's an ARM template is a JSON file, which looks a bit hideous, but it's really quite powerful in terms of the assets you can deploy. So you've got a server farm here, and that defines how much CPU, how much bandwidth your application's got. You've got a SQL Server instance, you've got blob storage, and you can see in the blob storage that it's locked down to this virtual network. So all of this is defined by a massive JSON template. So if we look at the website, we've got some app settings there. So we disable FTP by default, we disable remote debugging by default. So we're closing some potential security holes using the ARM template. So if you're on a deployment using the Azure pipelines YAML script, which I'll show you later, you get this in the Azure portal. So you got application insights for logging, key vault for secrets, a virtual network for all the assets to sit on, SQL Server and database, blob storage, the app service, and an availability test to keep pinging it to make sure it's alive. So that looks like this when it's deployed into the web. So I've just deployed it on my own website here. And here it just tells you, OWASP top 10, 2013 and 17. This is what using the template helps you with. So why automate? I mean, you can do all of that by hand, but there's some really powerful reasons why you should be automating these as much as possible. For reproducibility, so when you're deploying through the environments, you're deploying for like integration, regression, QA, UAT, and production. You're always deploying the same thing. So if someone forgets to disable FTP on the production, the QA environment or the production environment, that can't happen with a template. It always happens, and you can test it. So at each stage, so it's when you get to production, it's always a very boring process because it happened so many times before. If you need a UAT environment or a PAT environment or one for security testing, it's very easy to parameterize that on template I've just showed you to give yourself a completely new environment and deploy to that. And also rolling forward. So if you get a security defect, there's a 0-day vulnerability in some component you're using, for instance, you can fix that and very quickly deploy through the environments and out into production and fix problems. So what that means is your continuous integration and deployment pipeline is your heart of security because it enforces all of those rules. It enforces the checks and the balances and the testing and the deployment and make sure the deployment happens in the right way. Okay, so this is what an Azure Pipelines template looks like. So this does my build and unit tests. So here I'm setting up a Sonar Cloud connection, doing a NuGet restore, VS build steps, then running my unit tests, running Sonar Cloud analyze, and then various other security checks. So OWASP dependency checker, white source vault, etc., etc. So if you scroll down a bit, so once build and unit test is passed, we go on to acceptance test. Now it requires we deploy to integration. So this is when we run the pre-deployment steps. That sets up Cloudflare. We deploy the Azure resources in the ARM template I've just showed you. We deploy the website to the app service and then lock down the app service to Cloudflare. Configure the unit acceptance test and run the acceptance test against our deployed instance. So that happens on every check-in, again, guaranteeing security, or at least giving us the feedback so we can maintain security. So here's the latest build. If I go into edit here, you can see the same sort of template, and there's a lot of variables that are injected, so like secrets, for instance. So here, my Cloudflare user service key and my developer IP address is an encryption password. So all of those are injected at runtime and into the ARM template and any web.config that needs them. So it's not possible for anyone to see those. So a lot of these use extensions from the marketplace. So a lot of the security tooling which runs on check-in comes from this marketplace. It's very easy to set up. So just do a quick search for instance, the OWASP dependency check here. So if I click on here, I get it free, and then it takes me to an ads screen, so then I can add it into my subscription. What that then means is then I can add in this step here. Now, the best way at the moment, I find, so the YAML file is a bit difficult to edit, but if I go in here and go OWASP dependency check, and then I can put in all these variables, and it gives me some information about each of them. If I'm doing it from this editor here, I don't get that IntelliSense. So I find this a good way to prepare the path, as it were, but then check it in, so it enforces it on every build. Okay. Right, so what are Azure pipelines doing? So does NuGet restore, npm, build and package, runs the security unit tests, does security code analysis, security component analysis, checks the platform for security bugs, does an anti-malware scan, scans for credentials you shouldn't have checked into code, publish the artifacts to a server, then sets up the ARM template, configures the firewall using PowerShell, deploys the build to the integration server, runs the acceptance tests, and then does dynamic analysis, in this case, OWASP ZAP against it to get some more security feedback. And then after all that's done, you can tear down the paths. So we only use it for the time that for all of this is running. So how are we going to do pull left security? So this diagram's lifted from a book, which encapsulates most of my process. I'm perfectly happy to credit at the end. So here we've got a developer, and he's considering doing some changes to some code. So at that stage, you're doing threat modeling, doing IDE checks. Then he's committed it into source repo. And at that point, you can do software component analysis, static analysis, security and functional checks. And then you deploy it, and then do acceptance checks, and it goes to production, and you're getting feedback. So at each of these stages, you can do various security testing, which ensures that you don't get, which helps you get a security view of your application. So yeah, in production, monitoring continuous vulnerability scans and automated runtime defenses. So go into all of these steps later. It's all about the tooling that we're going to use to prove that out as we're going through that. So first off, I'm going to talk about pre-commit, which is IDE checks and threat modeling. So lightweight threat modeling is a very powerful method you can use to detect vulnerabilities before you've even touched a keyboard. So in Agile, when the code is the design, where and how do you catch security problems in the design? So this is what lightweight threat modeling can really help you here. What are the threats? So we can understand threats by the STRIDE acronym. Spoofing, that's pretending to be someone or something that you're not, i.e. a cross-site request forgery. Tampering, sniffing or changing something at rest, in memory or in transit, e.g. SQL injection. Repudiation, doing something and denying you did it, e.g. weak logging, if you've got insufficient logging to prove anything happened. Information disclosure, giving information to an unauthorized person, i.e. if you're allowing a man in the middle of attack with a weak cryptography. Denial of service, degrading or preventing access to a service, i.e. locking out accounts, for instance, or elevation of privilege, doing something not authorized to do via indirect object reference attack in the OWASP top 10. So there's a very fantastic tool that Microsoft's come up with called the Microsoft Threat Modeling Tool, which is available from that link, that has a specific Azure template. So it's got all of those resources that we saw in the Azure portal, and it will tell you what the threats are using the STRIDE acronym, and then practical steps you can use to then counter those risks. Okay, so here's the application that we're deploying. You've got the browser with the nefarious actor trying to attack, Cloudflare firewall, the app service connecting to the blob storage, SQL database, and Key Vault, and you've got sort of a notional trust boundary. And then you've got all the interactions between the two. Here we've got HTTPS calls and some TCP calls. Now this took literally 10 minutes for me to set up by dragging and dropping items onto the page. So this should occur when you're thinking, yeah, regularly but really lightweight. So if you're thinking about adding in some new piece of infrastructure, then definitely you should use threat modeling at that point. So once you've got that, you can then go to the analysis view. So this looks at all of the different interactions you've got here, and then it'll tell you using the STRIDE acronym what risks there are associated with that. So here, for instance, 23, we've got an HTTPS interaction between the firewall and the app service, and it's so the risk is information disclosure. An adversary can fingerprint an Azure web application by leveraging server header information. So possible mitigation: remove standard server headers to avoid fingerprinting. See these links. So I think this is mitigated, and I've put that status mitigated. Server headers have been removed by code in http headers.cs, which is a class that I use on there. But if you didn't know about what server headers to remove, then those links are really useful for that. Here's another one, 27. So again, it's the same interaction. So it's another information disclosure. No, it's between the app service and the SQL database. So there's information disclosure risk between these two. An adversary can read confidential data due to weak connection string configuration. So the possible mitigation is, you should ensure encrypt equals true and trust server false. And there's some links there to give you more information about that. So I've set that to mitigated. Justification: mitigated by applying as suggested in the connection string. So even if I don't know about something, I can use this tool to understand what possible risks I might have. So let's go back to the design view again. So let's say I'm a developer and I'm engaged in CV-driven design, and I'll just drag on. I think, oh, like Azure Redis Cache, that looks a bit sexy. I'll have that. So I'll take this and I'll say, well, my app service wants to talk to this Redis Cache thing, and yeah, I want to talk back. Okay, so in literally a minute, I've modeled having an Azure Redis Cache interacting with the app web service. Then I can go to the threat list here, and I'll see there's a whole new set of. There should be a new set of. There isn't. It didn't connect. Yeah. Okay. So these haven't been mitigated. So. Right, so if you have a look here, there's a potential information disclosure risk between app service and Redis Cache. An adversary can read sensitive data by sniffing traffic to Azure Redis Cache. Ensure that communication at Redis Cache is over SSL TLS, and then there's some links there. So if I know nothing about Azure Redis Cache, using this tool, I can find how I can get a really decent baseline security layer. Okay, so onto IDE checks. This is where you can spot some really basic security errors. In my view, IDE checks are kind of the thin end of the wedge. A lot of them use pattern matching. So yeah, sometimes you get useful things out of them, but there's a lot more powerful tools you can bring to bear on this. So an ideal IDE check should have IDE integration, obviously. but also run on Azure DevOps. So if you forget to pay attention to it, it can potentially fail your build. Allow building of your own rules. Have a low false positive rate. And give code examples and links to tutorials to help you fix the security problem if identified. And now allow you to enable defining exclusions, because sometimes they get it wrong. Right, so I've just gone and the one I'm using at the moment is DevSkim. So let's say I'm glad I didn't use MD5. Okay, so here I've got a little squiggly that says, okay, weak broken hash algorithm, because basically it's just using pattern matching. So it's not, and it's in a text file, so I know it's not using it. So, you know, they have value, but they can also give a lot of false positives as well. So the packages I have evaluated, so DevSkim, it can find insecure hash encryption algorithms, insecure URLs, look for credentials in code. PumaScan has free and pro versions. It checks for secrets, compiler settings, and auth settings. Vera code, it does as above, but you need an account to use it, and can check for SQL injection. And there's also the continuous delivery tools for Visual Studio and Microsoft DevLabs. So you can do all the credential scanning locally. Okay, so that's the pre-commit. I've now committed my ideal changes into code, and it's starting to build. So at this stage, we can do static application security testing, software component analysis, and security unit tests. So more about that in due course. So what is static application security testing? So one of the tools I use is FXCops. There's also others, which I haven't looked into, PumaScan and Roslyn checks. So the Roslyn checks require changes to your code. And we're going into Sonar Cloud, which is SonarQube as a service, an online provider of code scanning. And then the Microsoft Security Code Analysis Toolkit. So there's 3 parts. It's a big suite of tools. And there's 3 parts that are relevant here: the credential scanner, Roslyn analyzers, and TSLint. And so that checks our application code, and then we can check the platform using the ARM template checker, using the Azure Security Kit. Okay, first off, FXCop. So this, you can check for a lot of things like code quality, design flaws, globalization rules, naming, performance, maintainability, blah, 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 and security, which is what we're interested in here. So you can catch insecure SQL, tell you if your class design is poor, look for insecure XML and data type definition processing, check that if you haven't put in anti-forgery token checks, if you've used weak cryptography, and deprecated security protocols, and lots more. So how do you use it? So you install the package, FXCop Analyzers. So that gets installed as a dev package, which means it's not part of your deployment. It just gets built every time you do build. And a word of warning is that you need a version that matches your build agent. So if they're incompatible, then you'll just it'll run locally, but it won't work in Azure DevOps or vice versa. Okay, so say I've done install package. Here is in my Security Essentials project, I've got the FXCop Analyzers package, and here there is the security rules enabled rule set. So what I do there is I copy that and then paste it into the root of the project. So here it is, the root of the project. And then one final step. So you just need that element there. And that means that that rule set will run each time you do a build. So it's as simple as that. And then you've got a load of security rules which get run each time you do a build. So if we have a look at the security rules for a sec. So here it's got all the security rules at the top. So review code for cross-site scripting, file path injection, LDAP injection, XPath injection, lots and lots of security checks here. So you can learn a lot about your code just by having these in. You can set them as warning or error. So an error will fail the build, an error warning, as you'd expect. So if you can have a look at an example of that. Right, so let's say instead of using SHA-256, I'm using SHA-1 and I'm getting some green squigglies that saying that this code uses a weak cryptographic algorithm, and I can get that. I can set that to fail the build if I need to. So another good way of checking a code is via SonarQube. So SonarQube as a service is known as SonarCloud. So it's free for open source projects, which I've got, and it's running as part of my Azure pipeline. It shows you what you've done wrong and how to put it right. So lots of bugs, security vulnerabilities, code smells, invalid CSS, deprecated HTML, performance issues, code duplication, and all that kind of stuff. All that kind of good stuff. You can analyze where bugs are clustered, if bugs got introduced in the Friday afternoon regularly, or if Joe, the developer, all lots of issues got clustered around his code, all that kind of stuff. And can fail the build if you need it to. Okay, so really easy to integrate. So first of all, of course, you add it via the marketplace in Azure DevOps, and then you do some setup here. So here is the project key that I've configured in SonarCloud, and then does analysis and publish the results. So I can get that report in the build if I want. So here's my Security Essentials project. It tells me I've got 38 bugs, 87 security hotspots, which I find incredible, but there you go, and 1 vulnerability. So let's have a look at that. Refactor this code to not perform redirects based on tainted user control data. Why is this an issue? So if I click on that, it gives me non-compliant code and what I should compliant solution. Let's have an actual look at my code. It's going, oh, right, so you're taking this string via the login method, you're passing it here to a redirect method, and they could potentially redirect to any URL. So so we need to have a look at that and fix that bug. Yeah, so and it gives you some remediation steps so you can really easily fix it. Okay, so more static checking. So Microsoft have done the Microsoft security checks, and there's a whole suite of these things. You can see them in the build pipeline here. Credential scanner, bin skim, and TSLint. So credential scanner, you don't want to check in your credentials into source control. So you can check for username, passwords, secrets, certificates, hashes, all sorts of sensitive data in your source code and build output. It includes 25 searches supporting 70 different file types, and it gives you an output, something like that in the build. It can fail the build for you. So it gives you something like this, pretty unattractive file. It said web.live.config had a secret in file found password, signature key, or stored credential. So yeah, again here it produces a report which becomes an artifact to your build and can break the build on security if you want it to, or just ignore the check. So other parts of MCSA, TS-lint, so that's checking TypeScript code for readability, maintainability, and errors and functionality. In terms of pure just security, you don't want eval, so it's got a rule to check you haven't used eval. There's some terms you shouldn't use for security reasons. No string-based timeouts, which can be used to cause denial of service. Use strict, of course. So Roslyn analyzers, a bit like FXCOP, so they integrate with the code and analyze the code as you're building it. Again, also on the build server. Yeah, can produce a report and break the build if required. So it's a bit pricey. You pay per organization in Azure DevOps, so 7,500 or 5,000. But you know you can have hundreds, thousands of projects within that Azure DevOps organization. So spread over that number, it works out quite reasonable. But I think there's more sort of larger corporations than smaller ones. So now we'll move on to checking our platform. So the Azure Security Kit can run security checks against your resource group. So that is your deployed ARM template in an Azure ARM template, what you use to set it up, your Azure subscription, and then also provide continuous assurance, monitoring, and telemetry. Now, I've used the first three extensively. I've not used the last two, so don't ask me any questions about that. It's constantly updated, so the very latest security advice is incorporated in running this against your either resource group or template. So you get really good feedback. And there's a website to go to. Right, so first of all, the resource group and ARM template checks. So for instance, if for an app service, it checks you've got HTTPS enforced using HTTP2, SSL bindings set correctly, web sockets disabled, FTP disabled, auditing and monitoring, all that kind of good stuff. You know, and another example, blob storage, it's locked down to a virtual network with HTTP access. CORS is not overly permissive and has filed access, soft delete for availability, that kind of thing. So now I'm going to do two demos. So first off, we're going to run it against our ARM template. So here I've specified in that directory website the ARM template, and then I've said, well, I can give it the live parameters. And here's a set of exclusions, so things I've determined that ARM vulnerabilities or false positives. So here it's giving me the CSV file. Then if you saw it, that it quickly whizzed past down here, and it's saying I've got 16 high importance checks, 12 have passed, 4 have failed, and then medium and low checks. So here it's saying I need to use Active Directory admin and enable threat detection server. So here it's analyzing the ARM template, and it's saying, well, I'm expecting these settings to be set in the ARM template, and this is the expected value of that, and then a description of the bug. So yeah, these are on all failed. So you want to just pay attention to the failed ones, and then think about modifying your ARM template to provide better security. Right, so now I'm going to run against the resource group. Okay, this is where I didn't sacrifice enough goats to the demo gods. Okay, so this is checking through everything that we saw here. So it's looking at all the configuration parameters. So your ARM template said you had this. This is what you've actually got installed. So it's checking what I've got installed. So what I've also suggested, set it to do is generate a fix file. So that's a PowerShell script that I can run directly afterwards, which will fix all of these security problems. See, it's checking the virtual network as we speak, then it's checking the SQL database. So this is developed by Microsoft developers, or developers at Microsoft who want to promote good security. And it's constantly updated. So a lot of these tools will run with the very latest threats and mitigations. So they should be run regularly on your projects. And each time they run could show up different things, even if you'd fixed them previously. So again, this produces a CSV file and also the PowerShell script for fixing things. Obviously, we're not going to run that PowerShell script because we're a DevOps environment. We want to modify our ARM template and the PowerShell script so that it gets pushed through, put in source control, and tested at each stage. Okay, I'm going to leave that to run. Just one note, you can define an exclusions file. So in my project here, I've got this, I have an exclusions file, there you go. And that's the ones I've said of the CSV file it produces that I'm not interested in fixing. I think are false positives. So that will stop it failing your build if it's in the exclusion file. Okay. So next on to software component analysis. So this is things like NuGet packages and NPM packages. There you go, I didn't finish in the end. So you've got a couple of tools you can bring to bear here, the OWASP dependency checker and white source bolt. And then again from the MCSA, you've got an anti-malware scanner and bin skim. So more on those. So OWASP dependency check, it checks the vulnerabilities from the National Vulnerability Database, or NIST. So again, this is updated constantly because of an emerging threat landscape. Can spot all sorts of things: cross-site request forgery, cross-site scripting, denial of service, road code execution, buffer overflow, that kind of thing. Potentially limitless. Can generate false positives, so it needs some manual checking, and you create a suppression file if there's a false positive. So I'll be looking at that. Okay, so here's one I ran earlier. So I'm running dependency. You download it and you unpack it to a directory somewhere, and you get dependency check.bat, and then I'm scanning my security essentials folder. This is my suppression file. So these are the things I've judged that aren't relevant or false positives. And then I'm creating this output file. So I haven't run this for about a month. So as you can see, this is downloading the latest database of vulnerabilities. And it's identical process on OWASP, Azure DevOps. So this same check runs there. So this rather flashy report is the dependency check. So it's saying, well, there's all these dependencies, and there's a vulnerability ID, and then there's a confidence that it's identified it correctly. I thought that it would check it using hashes or that kind of thing, but apparently in the open source world that doesn't work because people like building their own dependencies, so the hash never works out right. So if we take this one, for example, and expand evidence, it's matched it on a vendor name and product name to work out whether it's right. It says, well, I'm highly confident that I've got a match here. Right, so let's have a look at this one. It's identified. It's saying it's a high severity one and it's highly confident it's identified it correctly. So it's saying CVE, and that one, the user resource create function services module, blah, 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 for Drupal uses a password of 1, which is obviously not great when creating new user accounts. You go, well, okay, so this library here may have been used in Drupal, and it may have been part of this vulnerability, but I'm not using Drupal here, so I think this is a false positive. So this is where I would create a suppression file, and I grab my XML here, and then copy it into a suppression file like this, which would be part of my build. And then I would continue the process of going through each of the vulnerabilities and understanding whether they're relevant to me or not. So the CVE code is from the NIST database. So this one here, Microsoft.NET Core Analyzers, CVE bar. A remote code execution vulnerability exists in .NET software when the software fails to check the source markup of a file. So remote code execution vulnerability. Right, well, I have no idea about this. So this is something that I should look into to see if this is a vulnerability for my application. So all of these tools we've seen so far should be self-service. OWASP Dependency Checker is no different. You should be able to run it locally, so the developer can check it before they check in code, and also reinforced as part of the build pipeline. I can get this to fail the build. There is a CVSS code here of 9.3, so it's part of Azure DevOps. Here, fail on CVSS, so I can set it to give it a threshold between 0 and 10. So if a new vulnerability appears in this check, then I can get it to fail the build if I want to. So White Source Vault does a similar thing. It shows NuGet packages and npm package vulnerabilities. It also shows for license risks and compliance. So if you don't particularly like GPL, it'll say you're using GPL in one of your libraries. That means you need to open source all of your software. There's free or paid versions. So if you get the free version, it covers 6 core languages, of which I'd be interested in C# and JavaScript. If you use the paid version, then it covers 60 languages. So this is one thing you can't run locally, but if you look in the build pipeline, you can see that it's created its own tab, White Source Vault Build Report. Anytime now. Come on, you can do it. Okay, there you go. So you got a flashy graphic and it's going, oh, right, jQuery 1.9.1. Ah, yeah, so the data grid I use in the project, that does use an old version of jQuery. jQuery before 3 is vulnerable to cross-site scripting attack. So the fix is to upgrade the version of jQuery, and it's a medium level vulnerability with the CVE code, showing you where the exploit happened and potentially how to exploit it. So there you go. There's can do UI web. It does use that for the data grid component, and it's quite an old version. So I need to fix that. So with all the checks you've done so far on the component analysis, if the developer checks in a piece of malware, which he puts the links into that someone can download, none of the checks so far will pick that up. So the MSCA has got an anti-malware task that checks for malware using Windows Defender. Obviously, you need a Windows build agent as part of Azure DevOps in order to do that. Finally, bin skim. So this helps you find outdated compilers, ensures using the most secure compiler settings, checks binaries assigned, and that kind of thing. So this is more if you're building a desktop application where potentially a malicious actor could substitute some DLLs in there, and so you can check that the DLLs really talk to each other if they've got strong crypto and strong signing. So at this stage, you can start doing security unit tests. So the Security Essentials project has got some examples of these. You can check the hashing and encryption algorithm work both ways. The email templates contain the anti-phishing warning. You've got a strong account creation and password reset process enforced. Companies like Netflix hash important code. So something to do with authentication or finance gets hashed. If a developer changes it, it will fail the hash test. And then the security team will get identified that a critical piece of code has been altered. And finally, there's a test that checks that the correct authentication is applied to controllers. So it goes through each of the controllers and checks that there is an authorized attribute applied to them. And on this particular one, that there is an admin role assigned to that. So if a developer comments it out for whatever reason, it'll start failing this test. So this test, again, via reflection, it checks all of the controllers and checks that anything that's post, put, or delete is decorated with a validate anti-forgery token. So this, you'll be familiar with, is to prevent against cross-site request forgery attacks. Okay, so finally, we've done our check-in, we've done our build, we've got some deployable assets. Here we can then deploy the code and do some dynamic scans and some security acceptance tests. So there's a lot of code that does this. So in the project, you've got Azure pipelines, so there's the continuous integration, the deployment, pre-deploy, which sets up Cloudflare and then post-deploy. In fact, I'm just going to show you. It's a lot easier than explaining it. Yeah, so all the Cloudflare stuff is via REST calls. Cloudflare has a fantastic REST interface. Creates a resource group, blob storage, and key vault. Sets up the secure keys in the key vaults. Cloudflares and removes IP REST restrictions, so Azure DevOps can deploy to it because it needs to bypass Cloudflare for that bit. Post deploy, so that re-enables the IP address restrictions. So as part of a pen test, I was asked, can you prove that Azure are actually updating their platform infrastructure? So what we said is, well, we'll do this check here that checks the OS version of the PaaS and logs it each time. So we can show over time that actually Azure is updating the version number. And then it does some HTTP calls to wake up the site after deployment. So there's loads of free engineering there. Feel free to go and steal it, and that does automates all the site for deployment. So we're going to use OWASP Zap as a dynamic scan. So I've heard this described as a sort of pen test light. I mean, it is much more of a toy than a proper pen test, and pen testers earn a lot of money because they have a very skilled job. But what this is good at is providing some useful feedback on your security posture by actually accessing your website. So it can check HTTP headers, it can perform fuzzing and directory traversal attacks, port scanning, attack WebSockets, attempt cross-site request forgeries, see if it does information disclosure and report that back, try SQL injection, reverse tab nabbing. I have no idea what that is actually. Make sure you've got HSTS set. So there's some header stuff, but there's some more complicated stuff like directory traversal, SQL injection, which requires actually interacting with the website. So yes, you shouldn't do this against a website you don't own. This can alter the website because it will attempt to push data into the website. So don't do this against your production site. So how is this set up in Azure Pipelines? So we need an Ubuntu image to run this. All the other ones just been using bog standard Azure DevOps build agents, but this actually has to run on Linux because it's built in Java. And you set up, well, I'm attacking this URL and I'm using this context. I'll tell you more about what context is in a minute. Then you've got this horrible bash script. Now, this is lifted lock stock from the marketplace. You don't really need to know how this works other than to say it takes the output from OWASP ZAP and converts into something that Azure DevOps will understand and then publish via this report here. So there's some publishing steps and you get a nice report out of it. Right, so this is OWASP ZAP. So I've given it a context, and it's exactly what Azure Pipelines are going to do. So a context you can describe as like it's teaching OWASP ZAP how to interact with your application. Yeah, what to include. Any URL with security essentials in it, and what to exclude. Any links that go to things that we don't own, like White Source Bolt, etc., etc. It's built, we're giving it clues. We're saying, well, it's built on SQL Server, and so don't bother trying any CouchDB attacks on this application. It's using this language. It's on a Windows OS, so don't try using Linux attacks. That allows it to hone in on how to attack your application correctly. Then you teach it how to log in with it. So this is the authentication URLs and teaches it what the post data looks like to log in, and gives it a couple of sample users, so an admin user and a normal login user, and how it manages sessions. So once you've done that, we can do attack. So it has two stages: spidering, which is just sort of going through each of the URLs, seeing the application, how it's tested, and then attacking, which is actually going the URLs, trying directed traversal, trying SQL injection, trying the cross-site request forgeries. So what you get out of the end of it is report looks something like this. So thankfully we've got 0 high-level alerts, 5 medium, and 7 low-level alerts. So it's saying here that my proxy is leaking data, and it can potentially use to do tracking. So I need to have a look at that. My content security policy is saying style source includes unsafe inline. Yeah, it's that library for the data grid again. So it requires unsafe inline, which is a potential hole in the security. So I need to fix that. And yeah, again, script source unsafe inline for the same reason. So again, it's feeding back the state about the headers, the cookies, any vulnerabilities it's found. So I can improve my security posture before a hacker does. Attempts to find it. I'd say the ZAP version that they've got on Azure DevOps is pretty good, but if you're running it locally, you can enable all sorts of different add-ins and modules, which will give you a more thorough check. I've got some that run for hours and hours, whereas the Azure DevOps one will usually run in minutes. So we're getting more feedback about our security, and you can do that via acceptance tests. So if you want to prevent throttling, so credential stuffing attacks, that's like forced logins, you can validate that that's working through an acceptance test, and the Security Essentials project does that. You can ensure that the correct HTTP headers are returned, the account process is enforced, the content security policy and certificate policy violations are logged correctly via report URI. A user registering with a pwned password via Troy Hunt's pwned password facility, which is excellent, will be shown a warning. Okay, so I'm just going to, if you have a look at the security centered project, we've got this acceptance test project here, security. So this is using spec flow. So the scenario will log a content security policy violation. So it's trying to do some credential stealing here via an evil site, and it's just checking that it's logging it okay. This one here. Okay, so this one is checking for headers. So extreme options deny, no sniff, all the familiar stuff, content security policy. So this application will prevent a brute force login attempt. So navigate to the website, log in, put in bogus password, try a different password, try another different password, try another different password. And then you're shown you've requested this resource too many times in the last 60 seconds. So you get four tries within a minute, and then it gives you an error message. So this will slow down massively any kind of credential stuffing attack. So the acceptance test will prove to you that your security mitigations are working correctly. Oh, and this is the pwned password check. So I think. Yeah. And then you get a nice graphic like that shows you these tests have passed in production against your deployed instance. So this happens on every single check-in. It deploys the environment, it deploys your code with your changes, and then it runs a security test against them. Again, preventing security defects from getting out into production. Okay, so now we've deployed and we've got production code. We can do vulnerability monitoring to show that our system is available, and then continuous vulnerability scans. So as part of the ARM template, it polls the site from the central US and UK West. So you get this nice graphic, and then it alerts if the site goes down for more than 3 minutes, which is quite useful. Particularly if you're getting a heavy load or under attack, then that could degrade your availability as well. So you get alerted immediately, rather than next time I meet Kevin at the at dotnetsheff and he goes, hey, your site was down last time. I go, oh yeah, okay. It tells me within 3 minutes that the site was down. So in terms of Azure, so this is once it's deployed, you can go something called the Azure Security Center. It's a center for alerts and recommendations. So this is a really powerful resource for promoting best practice of security for all Azure resources. So you get a kind of graphic like that. It says we've got 7 total recommendations, 5 high severity, etc., and 8 healthy resources, thankfully. So you're similar to with AZSK, it can tell you, it helps with securing transparent data encryption, accessing assets, auditing, ensure you've got diagnostic logs enabled, cause access, loads of stuff about VPNs, encrypting data, denial of service protection enabled, 2-factor enabled, whether that's on a subscription, and then ensures your storage access should be firewalled. So if you've got a VM, you need several agents to be installed. I think I did a VM for the first time in 3 years about a month ago, and you need 3 Azure agents on there to do various parts of the checks on the VM. And there's a lot more to go at than on PaaS. Okay, so you've got this nice dial called Security Center. This covers all my applications, not just Security Essentials. And you get sort of a nice dashboard of things you need to act on when it eventually wakes up. Come on, don't do this to me. Okay, there you go. Right, so here's my security hygiene. I've got an overall score of 55%. So say I was going to regulatory compliant, it's saying me that 39 of 45 checks of PCI DCSS have been passed. So this is specifically the platform ones. It can't tell you anything about the other platform ones. And you just get a piece of text that says you need to do this and that. But the platform ones it can tell you about. So if you go into the recommendations here, it says, I've got one of one unhealthy resources. I need to remediate the vulnerabilities. So advanced data security should be enabled in your SQL service. Oh, that's good, that's completed. But vulnerabilities in your SQL service should be remediated. So I can click straight into that and go to see what the vulnerabilities are. And it's giving me an overall score for my security position. So again, I can glean as much information as I can out of this. Oh, that's a quick fix, I like that. And it'll show you how, it take you straight to the page where you can fix it. Obviously, we want this checked into our ARM template, so we can promote it through different environments, but you can do the quick fix directly from this page if you want. So this, again, feeds back security information into the requirements. Okay. So one of the things you can activate on the database is vulnerability scans. So you get an email once a week that looks something like this. You've got total 5 failing checks, 45 pass checks, high risk, medium risk, low risk. It's in the Advanced Data Security Blade in Azure. Again, that's some good feedback on things you need to change. You can provide checks on that you need to classify sensitive data, set correct setting of database owners, restrict via firewall, guest user disabled, transparent data encryption enabled, that kind of thing. So I'll just point out that stuff that's not checked anywhere else. So what I've learned when I was going through the process assembling all this material is at each stage I was learning something new. There was never one stage that was like the silver bullet or showed me more than anything else. Every single stage had value, and I think that's the whole process is really powerful for me. So in today's talk, there's other things that we've not talked about. So obviously the Azure portal is key because you can bypass all those security checks. So you need to employ two-factor authentication or limit the subscriptions to certain users. And your CI/CD pipeline is like the backbone of enforcing security because all those security checks are automated. And the nefarious actor could go in and disable whatever checks they wanted and pushed a vulnerability through into pipeline. So securing that is important as well. Code reviews are really powerful. So in the DevOps report for 2019, it identified code reviews as one of the most powerful methods of finding vulnerabilities. And as I said before, pen tests kind of inform the process. They're not how we do security these days because we need to do so many changes iteratively at a high cadence. So a pen test will show you, well, do I need to do more static analysis? Do I need to do more checks in the IDE? Do I need to do more dynamic analysis? Is there something that the Azure platform can help me in feedback security that way? Pen tests are kind of like, 5 out of 10, you should have tried harder. By the time it's got to pen tests, it's failed because the stuff that's been pen tested may have been in production by 6 months. So it's always worth reviewing the process after a pen test to see how you could do better. So in summary, security defaults means fewer security defects. So with the Security Essentials project, you've got a very secure application code and platform code that's been pen tested over many iterations and checked using the checks I've highlighted today. Automated deployments means security defects can be fixed faster. Roll forward means you can get something into production very quickly. We've looked at things we can do at the design stage, lightweight threat modeling, not a bureaucratic process, something that provides real practical steps so you can secure your code. We've looked at IDE checks and what they can add and show you about your code before you even check it in. We're pulling this security left, so earlier in the process, as early as we can really, so we can identify those security defects earlier where they're cheaper to fix. At the CI stage, we can do static analysis and component checking So we used, looked at a number of tools you can use to do that: FXCOP, Sonar Cloud, AZSK, and the MCSA suite. And then EOS Dependency Check and White Source Vault for the components and NPM packages you rely on. So then we do a deployment. We've got a secure automated deployment which deploys on every check-in. And then we do dynamic analysis using OWASP SAP, and we ensure our security using security acceptance tests. When we're in production, we test for availability to make sure we know our site's up and it's not being hammered by someone. And we're getting feedback into our requirements from the Azure Security Center and the continuous vulnerability scans. As I said, no tool is a silver bullet. Each has its own specialties, and I've learned something at every stage of the process. So there's a few resources here. The diagram that I've nicked from and the process that I follow is from this book, DevOps Security Software Through Continuous Delivery. That's a free book you can get from O'Reilly. I would highly recommend it. So it steps you through the whole DevSecOps, what I call DevSecOps process. And it's not specific to .NET. It's cross-platform. There's a couple of good Pluralsight courses there that cover some of the tools I've been talking about today. Then there's the Azure Security Best Practices. So this is kind of like the AZSK and the Security Center diluted into a document. It's a really, really well-written document that tells you, if you're on an app service, these are the security things you need to consider and how to set that up. So that's really good. If you're interested in DevOps generally, and it's July, some of you might be going on holiday, I'd highly recommend the Unicorn Project by Gene Kim. So it's a good book on taking a monolithic 6-month, 9-month deployment project right through to DevOps with a really good security case study as part of it. It's very readable, very enjoyable. I would highly recommend it. So there's the URL for the code and the slides. And please contact me on Twitter or LinkedIn if you have any questions.